Okay, AB Calculus, section 7.3, page 9. Alright, here we go. The base of a solid in the region enclosed by y is the square root of x. Here we go. Here's y equals the square root of x. This one here. The y-axis here. And the line y equals 3 here. That region okay, now the cross sections by planes perpendicular to the y-axis. Perpendicular to the y-axis are isosceles triangles with one leg in the xy plane. So here are my isosceles triangles. One leg right here in the xy plane and perpendicular to the y-axis. It's like that. Perpendicular to the y-axis. See all those isosceles triangles there? Isosceles triangles are just standing up on end like this. Okay? Putting our cross section in here. Here's your cross section. It's the thickness right there. You should see that that's dy. And we have an isosceles right triangle. Where this is that. Alright, so when we want to find this volume, we are going to add up a bunch of triangles. And 1/2 base times height times thickness. Alright, that 1/2 can come out. Now, looking at what we see, this distance right here is a horizontal distance. That's some x. That's this distance right here. And because this is an isosceles right triangle, that's also x. So we have 1/2 base, which is x, times height, x, times thickness, dy. And so that's 1/2 x squared times dy. I have to replace out those x's with y's. So let's come back up here, and we know that y is the square root of x, which means x is y squared. So we have y squared squared dy. And our bounds, where we start slicing to where we stop slicing, we started down here at 0, and this horizontal up there was at y equals 3. So we're going to slice from 0 to 3. When we anti-differentiate here, we have 1/5 y to the 5th, evaluated from 0 to 3. 1/5 times 3 to the 5th minus a 0. 3 to the 5th is 243. So we have 243 over 5 times a half, 243 over 10. And there we go. Sorry, the sun's getting a little glary here to try and finish this up. Okay, the solid lies between planes perpendicular to the x-axis at x is negative pi over 3 and x equals pi over 3. The cross sections perpendicular to the x-axis are squares whose bases run from y equals tangent x to y equals secant x. Oh my goodness. Alright, let's put a couple of things in here. Here's negative pi over 2. Here's pi over 2. And we know tangent does that. Here's y equals tangent x. Y equals cosine. I'm going to erase this out of here in a minute. There's y equals cosine x, just between negative pi over 2 and pi over 2. But we want secant. And secant's the reciprocal. And secant's going up like that. And up like that. Let me go back and erase out my cosine because it's getting crowded in here. Alright. Well, right now we do not have a closed area. So, we need to go back and look again. We want between x is negative pi over 3 and positive pi over 3. Alright. Well, negative pi over 3 is right about here. And positive pi over 3 right about there. So here's our region. There's the base of the solid, is in between these. That's the base of the solid. And we have squares. Where's my squares? There's my squares. And the squares are sitting like this. Okay, sitting just like that in there. Alright, so to find volume, we are going to add up a bunch of squares times thickness. There's your cross section. Oh, right there, that tells you it's a dx cross section. Cross section. Base of a square in here. Okay, now that length right there is our side length. Well, how long is that? Isn't that the y to the secant curve minus y to the tangent curve? Or secant x minus tangent x? That's this distance right here. Secant minus tangent. That's squared. Dx. Bounds here would be from negative pi over 3 up to pi over 3. I better put that one in here. That was pi over 3. Negative pi over 3 up to pi over 3. And I will let you work through this on your own. And if you can work through that on your own and show me all the work, I'll think about giving you some extra credit. Right there, 4 square root 3 minus 2 pi over 3. Okay, thank you. Please take a look at page 10. There are some wonderful, wonderful videos there. So take a look at some of those and see if that helps you figure out some of what these things look like if you have a tough time visualizing. Thank you very much.